just say next slide when you want your next slide.
That'd be easier. Yep, thank you. Sorry for this. Yeah, so Garnet Gregory, Regional Materials Manager for Main Roads WA, out in the Wheatbelt. Elaine's work has a great segue to this presentation when we get it up. And this is really just an update. This is an update to a previous presentation I gave, I think about 3-4 years ago, to the DIG conference, as we embarked upon a number of projects in trying to mitigate the spread of dieback in main roads operation, in particular the Wheatbelt. Why the Wheatbelt? Because the Wheatbelt has a number of very peculiar areas. We have the forest to our west, through which Albany Highway and Brookton Highway traverse. We have a lot of cleared land, which has threatened ecological communities hiding within our road corridors and those of the local government network as well. And these communities are not found anywhere else in the world. So they're quite precious, not only to us in the Wheatbelt, to everybody. So we're undertaking a number of projects to try and improve our operations to reduce the risk of spreading Phytophthora through these very precious communities. So we'll go to the first slide after the opener. So we have 3 projects. Whoop, back to the first one. That's it. The 3 projects are. Now the first one I introduced a few years ago is the Albany Highway Fallow trials. These trial sites are located in the Jarrah Forest, adjacent to Albany Highway, around about 60 kilometres down from Perth. We have the second project, the Metham Sodium project. Both the first 2 are well advanced. And the third one, which is extremely important, and the last one, is the big question: does dieback exist in gravel road building materials sourced from farm paddocks? Because in the Wheatbelt, well over 95% of materials are sourced from cleared farm paddocks. Next slide. So Albany Highway Fallow trial. So this started off a number of years ago to prove or disprove a theory emanating from Giles Hardy from Murdoch, that the pathogen could be eliminated by keeping the land fallow, in other words, removing all hosts and maintaining that status for a period of time. So it's been 2 years in the planning to get this up and running. It was constructed in 2017. There's 2 trial sites. Why there's 2 is, one, they've both got slightly different orientation. One is on a flat orientation, whilst one is on a slope. So we just wanted to see if the geography had anything to do with impacting the spread of the disease in these trials. So both trial sites are sprayed twice per annum. Now that's not fixed. It just happens that an autumn spraying and a spring spraying manages to keep everything void off the trial site. So it turns out to be twice per annum. And that's sprayed with a mixture of herbicides to make sure everything's knocked. Both sites have been sampled twice previously to this year. They've been sampled in autumn, mainly. The idea of sampling is to sample when the soil is moist and still some residual warmth in the soil, because we know the pathogen likes those conditions. But previously it's been done in autumn. But this year it's going to be different. We're going to be sampling it imminently, probably later this month to early next month. So it'll be a first spring sampling. So we know the soils are moist coming out of winter, even though it's a low rainfall winter, but the forest area actually does get a lot of rain. and the soils are starting to warm up now as we approach the equinox. So this project is a collaboration between Roads WA, DBCA VHS and CPSM Murdoch University. Next slide. So these are the two, just a rough graphic of the two trial sites located in the forest. One's close to Herald's Road, one's just a bit further inland. Both have been assessed a number of times and declared dieback infested areas. It's a bit odd when you view vertically from the satellite. It looks like a fairly open woodland, but you'll see in subsequent slides it's quite heavily wooded. Now the polygons that you see there, the actual trial area is the centre portion. The yellow area is the outer portion, or the buffer zone, as we would call it. And that's to protect the inner trial site for any contamination coming in. So if we go to the next slide, you'll get a view of the trial sites in construction. I can't control the cursor, but you'll see here, this is trial site 2. We have an outer trench and we have an inner trench. Now the outer trench is to sever all horizontal routes coming into the buffer zone, which is a 20-metre wide buffer zone. The trench isn't dug to a specific depth. It's dug all the way down to the very hard lateritic duricrust, which sits under the loose gravel. So it does go up and down a bit. The inner trench is dug also down to the lateritic duricrust, and that inner trench is to control the flow of water both onto the trial site and off the trial site. So the trial site is that centre portion that you see there. Next slide. Both trial sites are well and truly secured by a perimeter fence with a locked gate. What you see in the front there is what we call a stone bridge. It's manufactured out of 30-odd mil railway ballast for vehicles to sit up on and do their clean down. The trenches are filled just in those two spots past the gate so that we can get in onto the trial site with the railway ballast, and that allows water to flow through the ballast that's collected into those two trenches. And then the assessing teams have access easy and out of those two trial sites. So a fair bit of expense has gone into the construction and the maintenance of these trial sites. I've had one nutter cut a fence a few years ago. Obviously you can't see what's inside, so you have to cut the fence to get inside to see there's nothing there. But anyway, that's what happened. So we've sewn that up, but generally they're not interfered with. So they've been there a number of years now, and hopefully we will continue this trial for a few more years in the future. So if we go to the next slide. Hope you can see that now. So these are the results of the last sampling. So 1,046 individual samples were taken, and they were bulked up to 146 bulk samples, and they had been baited. And it's proving that from the results from this sampling and the subsequent one before this, the one before it was very similar to this in results, other than the control. If you see the control, then it's only got 2 positives. The control is actually in a dieback infested area just outside one of the trial sites. Why it revealed a very low count of positives this year, the trial sites unfortunately went through a prescribed burn, which destroyed most of the species in the control area, which is unfortunate. So we may get an increase this year with some of the sproutings in the control area, because we do target those species for the testing to check for the PC. So we actually have proven we've eliminated the dieback in the top 300 mil of both trial sites, but it still exists in large root particles up to 2 meters below. But over time, we're hoping, and hopefully this next sampling will indicate a drop in the positives again from those figures you see there. So if we go to the next slide. So as I said, next sampling is going to occur this spring. This will give us a comparison between autumn and spring. So looking forward, if dieback is still detected, we may push the next sampling out up to probably 5 years since clearing or more, depending on what we get back. Should we ever get to that point of proving that we can eliminate Phytophthora by fallow, then we will plant the trial sites with susceptible species such as Banksia grandis and allow them to grow for a period of time to verify one way or the other whether that result was correct. And should we ever get to the end, well then we'll just hand the trial sites back to DVCA to rehabilitate as disease-free areas. So it's heading in the right direction. We haven't got there, so Giles will have to hang on a bit longer. But hopefully this next sampling will show those positives to be even less again. There's no lignotuber sproutings on either trial site, so it's encouraging that nothing's trying to resprout from bigger root lumps further down. The question is, how long does this pathogen hang on to a dying lump of a host, and can we hang in there and determine that time when that pathogen gives up? So stay tuned. So we're not there yet. So that's the summary of the Albany High Fallow trial. So we go to the next project, next slide. Metham Sodium, next slide. So this is an upscaling project of Elaine Davison's prototype work that she did in 2012 in conjunction with Roads WA and B&J Catalana of Brunswick. And you've seen her presentations and her paper presented on this subject. So this took 1.5 years in planning. We did the upscaling project last September, almost exactly a year ago, where we managed to dose 2,300 cubic metres of undeterminable gravel with Metham Sodium at Culford. Culford is the commercial partner in this project. Culford sits just south of the forest, about 90 kilometres south of Perth. There's a commercial operation sitting down there. Culford's part of that. In this project here, we dosed the gravel and formed long windrow stockpiles and inserted 250 slotted PVC pipes into the stockpiles, and they contained the bark plugs were containing the pathogen. A modified pug mill was used to dose the gravel with the metham, and it stacked the gravel into the stockpiles. The schematic you see there shows you the position of the PVC tubes and the approximate position of the baits within the tubes. The loose samples are just samples of baits, I think in the same manner that Elaine used in burley cages with fishing line attached. They were inserted about 200 mil into the surface of the stockpile and covered. So go to the next slide. So you see on the slide A, you have the pug mill up the top, dropping the treated gravel. The system for treating and dosing the gravel is in that head where you see that black shroud. Just above that is where the gravel is dosed with the Metham Sodium, and it drops straight into the stockpile. The gravel is wet, so because it's the reaction of the water with the Metham Sodium that evolves the toxic gas. Hence the person putting the tubes in is covered with the PPE to protect them from the toxic gas. So it was a fairly labour-intensive process. All the necessary PPE and OSH was required to protect everybody concerned. all the permits, approval, the training, everything was obtained through Culford for this project. You see down the bottom the slotted PVC tube, and the end that sticks out, you'll see there's a little red balloon that was filled with water that was inserted there to seal the ends, prevent the MITC gas from escaping quickly out of the end of the tube. So it stayed within the tube. The slots enabled the gas to get into the tube and stayed within the tube to sterilise the plugs. Next slide. So the outcome. We had a separate control. A control pile was put to one side away from the treated trial, so the control is an untreated. So it gave 4 positives and 1 negative in the loose samples, which are just inserted into it, and then 8 positives and 4 negatives into the pipe sample into the control pile. Now the main stockpiles, there were 26 negatives of the loose and 5 positives. In the pipes, there's 216 negatives and 10 positives. Now that 10, I want you just to concentrate on that figure there, because that's what we're going to go to in the next slide in a minute. So, but you'll see the vast majority came back as negative. So we sterilised the vast majority of plugs in the slotted pipes, which was a very good outcome. So if we go to the next slide. Eight out of those 10 positives were located in that red zone down at the bottom of the stockpile, which I call the toe of the stockpile. Why is that? Which is the big question. And if you see in the left-hand bottom diagram, gravel, when it's poured onto a cone, segregates quite easily and the larger particles roll down the side. And you can see with the 2 hands, one's got a handful of fine material, the other one's the coarse. So we're believing that the coarse nature of the segregated material at the toe of the stockpile allows the MITC gas to escape very quickly and very freely, and does not treat those pine inoculated plugs, baits down at that level, which is an issue. We know from Elaine's work that we need to establish a water seal. A water seal means basically wetting the outer surface of the stockpile, which minimises the escape of the MITC gas out of the stockpile, so it can do its work before it does evolve and escape. So these are 2 things that we need to ensure that we establish going forward, so that we control the toe and we control the water seal. So if we go to the next slide, for those of you who are against the acronyms, I'm also against acronyms as well, but MITC, and you have to correct me, Elaine, if I'm wrong, is methyl isothiocyanate. So I'll go to MITC from now on. It's a bit of a tongue twister. So going forward, we will control the toe of the stockpile by putting a Metham treated bund around the large stockpiles, and the bund is those little areas that you see below, those little peaks at the bottom of the stockpile. And what that does is protect the toe of the stockpile from early loss of MITC gas. The bund itself is also manufactured from Metham treated gravel. It will then sit for its 28-day quarantine period to allow all the MITC gas to dissipate, and that is the recognised period for quarantine, after which the bund and the toe of the main stockpile will be removed, and it's removed generally with a very large front end loader, and that material is then placed away from the Metham treated gravel, and that will go through another Metham treated cycle itself to make sure that that's purified for future use. We're not wasting the material. So this is where we're at the moment. Culford, who are the first commercial supplier and treater of gravel with Metham Sodium, have acquired a very large water cannon, and they'll use that also to establish a good water seal over any stockpile that's Metham treated, just highlighted in that blue line. And that will sit for its 28 days to cure and kill the pathogen. Obviously, all this is sitting on a Metham treated gravel floor, so that 2,300 cubic metres that I dosed last year has all been wasted. In one regard, we're not using it for road construction. That is now the floor for a very big contract that's just happening at the moment. So if we go to the next slide. The other problem we had with treating gravel with Metham Sodium, there's a lot of words there, but essentially we wanted to check whether we could reduce the 200 metre exclusion zone during the 28-day curing period down. So we did some gas monitoring, but unfortunately at one site we did, at 100 metres, we did find we were above the safe limit for MITC gas. So essentially all those words are just saying, no, we can't reduce the 200 metre exclusion zone. Now this is going to be a bit of a problem for some commercial suppliers because they don't have large expanses of hardstand area. So it's something that they have to factor in, or they close their pit totally during that 28-day quarantine period. But they have to meet that at the moment. The evidence is that we can't afford to reduce the 200 metre exclusion zone. Next slide. So was the project 100% success? No, it wasn't, because we did get some positive baits return. So the success rate was 93.8%, which is good. We will mitigate those positives, which most of them came down at the toe of the stockpile with the bund and with the water seal. That's probably going to change in time as Culford get more efficient in their operation, and if others come on board, they may find other ways of sealing the surface of the stockpiles and do it more efficiently. These are still early days. Further work that's being undertaken is to establish a verification test, and Elaine and Emma O'Gara from DBCA are assisting Main Roads with that, where we can hopefully determine from a gravel sample that it actually was treated with Metham Sodium after the fact. And that's happening now as we speak. Also, Main Roads going forward will continue to treat gravel with Metham Sodium to control the risk of spreading the pathogen, and we will write and set a specification for the use of Metham treated gravel for Main Roads work. And that's going to happen very soon after a current project is happening. We've just awarded, more or less today, the first commercial contract for the supply of 30,000 cubic metres of Metham treated gravel from Culford. It's just under $600,000 contract. So it's a bit of a privilege, Elaine, to have brought your work up into commercial reality, and that happens this week. So well done to you. So this project, it's still ongoing. It's not totally complete yet. So Elaine, as I said, has got a bit of work to do to try and establish a verification for it moving forward. And it's been a collaboration between obviously Main Roads, WA, DBCA, Elaine and Culford Agri Industries. So it's a bit of a winner all around this project, and it gives Main Roads a good option to purify our material, hopefully from Phytophthora coming onto our roads in our networks in the Wheatbelt. So on to our last project. Next slide. Next slide. There's a lot of words in this, so I can just talk through this. So as in my preamble, these narrow road reserves are just refuges for a lot of our threatened ecological communities now. The question always remained, and has been there for a long time, are we actually spreading Phytophthora in our activities into these road reserves containing this vegetation which is threatened? For many years now, and don't forget main roads is coming up to a century old. It's been doing this for a long time, and we haven't answered the question. So the last project is to try and answer the question. The Wheatbelt is predominantly what is called dry land farming area. So dry land being below 400 mils annual rainfall. We do have a certain portion of it sitting just above 400, which is down the southwest, like Williams down to Collie in that area there. So we may be focusing on the above to 400 in part of our project and below 400 for the rest of it, because the bulk of the Wheatbelt sits below 400. And first thing is to do, there's two phases for this project. The first phase will be to establish what's been done before through the dieback industry and what research is applicable to our project. We'll scope up what the second phase will be, which would be the actual investigation side of it. I've employed Arbor Carbon as our project manager in this regard because they've been with us on all the other projects so far, so they have a lot of the knowledge on main roads perspective and what we're trying to achieve, and working very closely with DBCA in this as well. So we're trying to answer this question, and it won't be just for main roads, because local government also source a huge amount of their materials from paddocks and bushland. So these projects will go hand in hand for not just main roads, but for other users, even DBCA as well. So we've got funding sources for all three packages. Main roads are committed to try and come to answers to all these three. Not just for the Wheatbelt, because we know it has a broader impact through the Great Southern, Southwest and Midwest. And basically watch this space to what we find in the future. So I'm hoping that this last project will be completed in about a year and a half. So there'll be 2 out of the 3 done, and then the Fallow trial will continue for quite a number of years yet, depending on what we find this spring in the sampling. So essentially that's it. That's where we're at the moment. So at some stage, probably a few years' time, I could do another presentation and keep you up to date where we're at then. Thank you.
Thanks for that, Garnet. So we've got one question from the virtual audience, and then I'll take one quick question from our audience, and then everything else will have to go via email. David, did you want to read out?
So we have a question from another David Guess, who says, would fumigation be more effective if you covered the stockpile with plastic sheet or a tarp?
Yeah, no, we did tackle all of that, but people need to be cognizant of the magnitude of the volume of material. So main roads, we deal with cubic meters, and 30,000 cubic meters is a massive set of stockpiles. So the actual impost of placing plastic over gravel, which is evolving a toxic gas, means I'm putting more people at risk. So it's just better we spray it from a distance, because that's what the big water cannon's for. We can spray it from a distance, soak the outer surface of the very large stockpiles and let them sit. So we've got to be mindful that I don't put people at risk. And when you're milling around trying to put these sheets in, you've seen, most people have seen the wheat bins that are around, they have the huge tarps over them. But in this case, the gravel is actually evolving a toxic gas at the time that you want to put the tarps over them. So it's too dangerous.
Yeah, okay. That's, yeah. interesting to know. I actually had the same question in mind, so it's a good. And Dion had a hand up? No?
That was my question.
Okay, anybody? Ian?
This is Ian. Just Metham's treated gravel floor. Just wondered approximately how deep is that? Yeah, that's and how long will you be storing on that floor?
Yeah, well, I'm not sure how deep it is because I haven't been to the site. It's a commercial site and it's 2 hours drive from here, but I haven't seen the floor itself. The intention is that it's 50 to 100 mil thick to sit underneath the stockpiles to allow a bit of error with the loader operator scooping off the stockpile off the floor. Even if there's residual out of this 30,000 after because there's a number of contracts about to start up on Albany Highway, and the bulk of the gravel will be used. If there's any residual, it will also be spread as floor for future dosing. But I've always got to maintain that integrity on the floor so we're not contaminating anything. All machinery coming on site is controlled by Culford or must be cleaned before coming in. And they control that. They're very stringent. So it's all part of their pit management, and any commercial supply going forward will have to meet a very stringent pit management plan, which they have to submit to Main Roads because this will all be part of our specification for prior approval before they're granted permission to dose the gravel.
Thanks for dialing in.
I could just make one statement. The three projects may look a little bit ad hoc, but they actually join together to give Main Roads a series of options. So a number of areas of the state clear trees for the gravel, as Elaine pointed out in her conversation. The idea is that we don't clear dieback free, we go to degraded. If we can prove Giles' theory, then you could, if your planning was more advanced, you could leave it fallow, or then you can choose to treat it if you haven't got that time frame with Metham Sodium. So one thing leads to another. If we do find dieback in Paddocks, well then we'll treat it with Metham Sodium to mitigate that. So they're not ad hoc projects. One leads to another option for Main Roads. So they're all linked. Just tying it together. Thank you.
Thank you.